Okay, this video is about organic reactions for AS chemistry. This picture here shows you all the organic chemistry reactions that you need to know for your AS exam. The most important parts really are the alkenes, going to haloalkanes or halogenoalkanes, to alkyl hydrogen sulfates, to alcohols, and how halogenoalkanes can be transferred into alcohols, to amines, to nitriles. Certainly alcohols themselves, how they can be secondary alcohols can be converted into ketones, primary alcohols into aldehydes for partial oxidation or for complete oxidation under reflux. They can be formed into carboxylic acids. Okay, so now for the rest of this video we're going to concentrate on the reaction mechanisms themselves. So we don't need to know the reaction mechanisms of alcohols being oxidized into ketones or aldehydes and carboxylic acids, nor do we need to know about them being converted into esters. But what we do need to know are all these reactions here. Okay, now I've color coded it. So we've got in the orange electrophilic addition mechanisms, in the green elimination mechanisms, in the blue nucleophilic substitution mechanisms, and in the pink free radical substitution mechanisms. Okay, so there are four different types of mechanisms that we need to know. The first one we looked at was free radical substitution. Now remember that a radical is a species with an unpaired electron. So that's why we show an atom with a dot on it. Remember that during your mechanism you need to show the dot and to show which atom it's attached to. So if you're breaking a carbon-hydrogen bond and the carbon's got the radical, you put the radical on the carbon atom. Okay, we have seen the free radical substitution in two forms. One is in the ozone decomposition in the halogenoalkane notes, and the first reaction we saw was the conversion of alkanes into halogenoalkanes. Okay, both of these go via the halogenoalkanes are mediated by ultraviolet light breaking at either a chlorine bond or a fluorine bond or a bromine bond. The ozone decomposition is only for when you break a CFC, and so you form a chlorine radical only. Okay, in the blue we've got the nucleophilic substitution. Now remember, a nucleophile is an electron pair donor. So remember, N donor. It's got to be an electron pair donor. Okay. The examples we have seen have all been reactions of halogenoalkanes, and we've seen it when we use potassium cyanide in the presence of acid to form nitriles. This is very important because this extends our carbon chain. So for example, if you start off with 2-chloroethane, you end up with propane nitrile. Another example is reacting a halogenoalkane with excess, that's not times 5, it says excess ammonia to form amines. If you don't use an excess of ammonia, you will get a mixture of products. You won't just get the primary amine products. And finally, the halogenoalkanes with aqueous hydroxide to form alcohols. Now, this is in contrast to the elimination reactions shown here in the green. We've seen elimination reactions in both halogenoalkanes and alcohols. Now, the halogenoalkanes undergo a base-promoted elimination. The base we use is potassium hydroxide, but we use it in an alcohol solution, alcohol solvent, sorry. And changing to an alcohol solvent from an aqueous solvent means instead of getting the substitution, we get elimination, and we get elimination of the hydrogen and the halogen. So the hydrogen off a neighbouring carbon, neighbouring the carbon containing the X. Alcohols dehydrate, so they lose overall a water molecule, and this is mediated by concentrated sulfuric acid. Finally, we got our electrophilic addition mechanisms. An electrophile is an electron pair acceptor. Okay, most commonly we have seen molecules being electrophiles, so we've got a delta plus on our X and a delta negative on our Y. So this could be due to a polar bond. So in the example of hydrogen bromide, or if we've got say a bromine molecule here, so both atoms are bromine, and the electron-rich alkene induces a dipole into the bromine molecule, which repels the electron density, causing it to be an electrophile. Okay, so the 4 types of reactions we have seen. So the first is the reaction of an alkene with a dihaloalkane, the reaction of an alkene with a halogen, such as bromine or chlorine or iodine, to form the dihalogenoalkane, dihaloalkane. This is the test for alkenes. So given a shake of bromine water with an alkene, you see a colour change from orange to colourless. Or we've got the alkenes reacting with HX, such as like hydrogen chloride, hydrogen bromide, to form halogenoalkanes. We have got the reaction of concentrated sulfuric acid with the with alkenes to form alkyl hydrogen sulfates, or alkyl sulfates here. This is a very important mechanism. It has been asked quite frequently in AQA exams over the past few years. Remember that hydrogen is bonded to oxygen, sulfuric acid. It is not bonded to sulfur. And finally, we can make alcohols by direct hydration. So we use steam, a temperature of 300 degrees Celsius, 60 atmospheres of pressure, and a catalyst of concentrated phosphoric acid. Okay, what I'll do now is we'll go on to a new video which looks at each type of mechanism in turn. Okay, thank you for watching.